This is the second section of chapter 2 on measures of location and spread, and this section is other measures of location. Now, although we didn't mention it before, central tendency from the previous section is a measure of location, and actually it measures the central location, looking at what's going on in the center of our data. Now, we could look at what's going on in different places in our data. Doesn't necessarily have to be a central location. Now, we could use quartiles to see what's going on in our data, and quartiles measure what I call quarter locations. So imagine this diagram here represents all of our data. Well, what we've looked at before is our data, which is halfway, and we've looked at what's going on in this central part. What's the central tendency? And we've looked at what's going on in the center. One way of looking at that is the median. Now, remember from GCSE, we could also look at what's going on at these points at 25% of the way through our data and 75% of the way through our data. And at these places, we have the lower quartile and the upper quartile. Now, it wouldn't be A-level unless we had some new definitions and new symbols. Well, for the lower quartile, we use Q1. So if you see Q1, that's the lower quartile. For the median, we use Q2, like quartile 2, quarter 2. And for the upper quartile, we use Q3. Now, we don't have to stop at just looking at quarters of the way through the data. We could look at 1/100ths of the way through the data and divide our data up into hundredths. And percentiles measure 1/100th locations. There are also something called deciles as well, which measure tenths locations, but we don't need to look at those. So how do we express a percentile? So let's say, for example, I was looking at a piece of data. I want to measure what's going on 7% of the way through our data. I've just chosen that. Then we would call this the 7th percentile, and we'd write that as P with a little 7. So this can be anywhere from P0 all the way up to P99. So let's pick another point. So let's say I had a point here, so I'm just picking a random number, and let's say that this value here from the start was 83% of the way through our data. 83%. So we would call this the 83rd I keep wanting to say decile, 83rd percentile, and we would write that as P with a little 83 at the bottom. And we've got calculations we can use to work out or to estimate what these values are. So quartiles, quarters of the way through the data. So this will be the start of our data here. This will be the end of our data, smallest data value, largest data value. And percentiles, which divide our data up into hundredths, and we look at what's going on at a particular 100th of the way through our data. Now, what we need to be able to do is to find the location, the positions of these quartiles and percentiles. So this is the working. I'll go through a couple of examples in a moment. So if we want to find a position, the first thing that we do is we change whatever quartile or percentile we're trying to find as a fraction. We do that fraction times by n. That's the number of data values. We're going to get a number. If this value is a whole number, then the position of this quartile or percentile is between the whole number that we've just got and the next whole number. If, however, after doing this calculation, the value we get is not a whole number, then we always round it up to the next integer to get the position. So here's a few examples. Let's say, for example, I've got 17 data items and I want to find a position of Q3, the upper quartile. Well, I'll change Q3 to a fraction, that's 3/4. I then times that by 17. When I times that, after pressing the SD button, I get 12.75. That's not a whole number. So what do? I round it up to 13. So it tells me that the position of Q3 is the 13th value. Okay, here's another example. Let's say I've got 87 data values and I want to find the position of P21, the 21st percentile. Then I will change 21st percentile to a fraction, 21 over 100, times that by 87, and I get 18.27. Now it's not a whole number, so I always round it up. So if I round that up, it will be 19. So P21 would be the 19th value. And last example, let's say I've got 52 data items and I want to find the position of Q1. So I will change Q1 to a fraction. That'll be a quarter. So I'll do a quarter times 52. That's 13. Now this is a whole number. If it's a whole number, it means that the position of Q1 is between the 13th and the next value. So that will be the 13th and the 14th. So it's between the 13th and the 14th value. Example 4. From the large data set, the daily maximum gust in knots during the first 20 days of June 2015 is recorded in the Hern. The data is shown below. So we've got 20 values there. Find the median and quartiles for this data. So let's start by finding the median. Now the median we know we call Q2. So what do we need to do? We need to change the median to a fraction. That's a half. And times it by the number of data items, which is 20. So half times 20 is 10. Because that's a whole number, that tells me that the median is between, this is the position of the median, not the median itself, between 10th and 11th value. So the 10th value is 22. That's this 22 here. The 11th value is 23. So we want to find the value between those. So we add those together, divide by 2. So that's 45 divided by 2. So we're going to get the median as 22.5. So just write down Q2 equals 22.5. And then I want to find the quartiles for this data. So Q1, the lower quartile, change that to a fraction, which is a quarter, times that by 20, and we get 5. Again, that's a whole number. So Q1 is between the 5th and the 6th value. So let's have a look to see where they are. 1, 2, 3, 4, 5. So it's between 1, 2, 3, 4, 5, 6. So between 5 and 6 is between the 18 and the 18. So that's just 18, isn't it? I mean, I suppose I could do 18 plus 18 divided by 2, which is 18. So Q1 is 18. Then for the upper quartile, Q3. So that's going to be Q3, upper quartile changed to a fraction times by 20. That's going to be 15. So that means it's between the 15th and the 16th value. 15th and 16th value. So we know that's 10, 11, 12, 13, 14, 15. So it's between 25 and 26. So we'll do 25 plus 26 divided by 2. So that's 25.5. So Q3 is 22.5. So we'll just highlight those: Q3, Q1, Q2. Now, since we've been given the units in the question, they're not, so strictly speaking, we should write knots after all of these to show that that's the numbers that we're looking at, these maximum daily gusts. Example 5. The length of time to the nearest minute spent on the internet each evening by a group of students is shown in the table. Find an estimate for the upper quartile. Now to do this, we're going to use a method called interpolation. We don't know exactly what the value of the quartile is. This will be a method that allows us to estimate quartiles, the median, and percentiles. So the first thing we need to do is to work out which group am I going to find the upper quartile. So we're going to do that by actually working out the position of Q3. Then we can use the cumulative frequency to work out how far I need to go. So position of Q3, that is going to be 3/4, that quartile is a fraction, times by the total of the frequency. So now might be a good point to do the cumulative frequency. So 2, 27, 57 and 70. So 3/4 times by 70. Right, so this calculation gives us 52.5. So the position of the middle number, or sorry, of Q3 is the 52.5th number. Now where will I find the 52.5th number? It's going to be in this group. And these are the values I'm going to be using to help me estimate what Q3 is. Now I'm going to draw a diagram. This diagram should help me to work out where I'm going to find Q3. Right, so this bar represents this group here. And what I want, either side here, I want what the lower class boundary and the upper class boundary are for these groups. Now remember, these gaps need closing. So this will be 33.5 and this will be 36.5. So 33.5 and 36.5. Now if there are no gaps between these values here, you just write down the values that are here. These would be the upper and lower class boundaries. Now we want to work out whereabouts between 33.5 and 36.5 is Q3. So I'll just put somewhere on this line Q3. So this is the value that we want to work out. It's a number that we're estimating is somewhere between these two. We also know the position of this number. So, and that is 52.5. So what I've got here at the top are the actual length of time spent on the internet. So I've got the times up here. Q3 is the time that I want to find. And at the bottom here, I'm going to be writing down positions, and I've got this position here already. So these are going to be positions. Right, next bit, we need to be careful with the positions. So we want to write down a position where this group starts and the position where this group finishes. Now notice we closed the gap and we said, right, 33.5 here and 36.5 at this end. Because we've closed the gap, we need to also close the gaps with the frequencies. This group goes to the 27th value, and the 27th value is where this group starts if we're looking at continuous values. So when we put this position down here, it's not going to be the 28th value. It starts where this finishes. So this position is going to be 27. Then over here, this group finishes at 57. Then the next group starts at 57. So we'll put 57 here. So just take care writing these numbers down. First of all, if there's gaps here, close the gaps normally by adding and subtracting 0.5. Put down the value you're trying to find. Put down its position, its exact position, which we've worked out. And then write down the positions where the group starts and finishes. And it starts where the last group stops and it finishes here, the value we get from the cumulative frequency, and that's where the next group would start. So if I was writing down position values for something in this group, it would be 57 57th value to the 70th value. Now we can use this diagram and fractions or ratios to work out what this value of Q3 is. So for example, this gap divided by this gap is the same as this gap divided by this gap, or this gap divided by this gap is the same as this gap divided by this gap. Now there's lots of different ratios you can write, but I want to write it to make the working as easy as possible. So I'm going to do this gap here, so that this gap would give me 36.5 minus Q3, and I really want to avoid that. I'd really like to have a positive Q3. So if I do Q3 minus 33.5, so Q3 minus 33.5, I don't really want Q3 to appear again. So now I'm going to look at this gap. So this gap here divided by this gap, so that's 36.5 minus 33.5 is equal to, now I need to do the same gaps at the bottom. So I did this divided by this, so I do the same thing at the bottom. So this gap, which is 52.5 minus 27, divided by this gap, 57 minus 27, so 57 minus 27. So I just want you to have a look at what I've done. So that minus that over that minus that equals that minus that over that minus that. There are lots of different ways of doing it, but this way we end up with Q3 being positive and only appearing once. So the next thing to do would be to work out the values. So Q3 minus 33.5 over, then 36.5 minus 33.5 is 3. And then 52.5 minus 27 is 25.5. And then 57 minus 27 is 30. We can then multiply both sides by 3 and then add 33.5. So we'll have Q3 is equal to 25.5 over 30 times by 3, and then add the 33.5. That makes Q3 the subject. And that's 721 over 20, which is 36.05. Okay, so we're not going to round this. We'll give it exactly as it is for this. We won't round it to 3 significant figures. So these types of things we tend to try and write as exactly as possible. And then part B, I want to find an estimate for the 10th percentile. So the first thing I need to do is to work out the position of the 10th percentile. So the position of P10. So that'll be 1/10 times by 70. So it's the 7th value. And again, using my cumulative frequency, I'm going to find the 7th value in this group, 32 to 33. So 7th value in group 32 to 33. So I'm going to draw my diagram again to help me. So this group here, again closing the gaps, this group goes from 31.5 to 33.5, so 31.5 to 33.5. We're trying to locate the value of P10, so we'll write that on here. Then we want the positions of P10 and the ends of the group. So P10, its position, we've worked out, is 7. So we can put 7 down there. And then we want the positions of the beginnings of this group and the end of this group. So this group begins where the last one ends at 2. So position number 2. And this group ends at position number 27. So just like before, we've got our times at the top, we've got our positions at the bottom. So now we're ready to write our equation. So we're going to do very similar to what we did before. So P10 minus 31.5, that gap, divided by the width of the whole gap, the Clark's width, 33.5 minus 31.5, is equal to the gap from 7 to 2 minus the whole gap, which is 27 minus 2. So if we work that out, we'll have P10 minus 31.5 over a gap of 2 equals 7 minus 2, which is 5, over 27 minus 2, which is 25. And then we can rearrange that to find P10. So we'll do 5 divided by 25, so 5 over 25. Then we'll times that by 2 to get rid of the 2, and then we'll add 31.5. We end up with 319 over 10, which is 31.9. So obviously these are times, so these answers would be in seconds. So let's just highlight this. Our Q3, 36.05, and P10, 31.9. So you should now be able to do exercise 2C, which you'll find on page 27.